Hi everyone. We're going to graph quadratic equations or parabolas in vertex form. This is what vertex form looks like. In the next video we'll be putting them in vertex form, but right now we're already given vertex form and we have to graph. So the vertex is HK. Notice this is a negative here. The axis of symmetry is just your x equals h, and we already know if A is positive, the parabola opens up. If our A is negative, then the parabola opens down. And your HK is basically your new vertex here. Your axis of symmetry is right here, which is just your H here, whatever your H is. So X equals H. All right, so here's an example. This one's going to open down. But my vertex is going to be -2, 3. Why negative? Because this is really x minus a -2. If we come back to the original equation, remember this was a negative. So our formula is negative. So you have the negative kind of means opposite. So take the opposite. So our vertex is -2, 3. So I'm going to plot this as -2 and 3. So there's your vertex. We know it's going to open down. All right, our axis of symmetry is just x equals our h. So this is h comma k, so that's x equals -2. So I'm going to draw my axis of symmetry. It's right there. And now I'm just going to plot 4 points. I'm going to evaluate the function for 2 x values less than the x coordinates. So basically, if my x is -2, I'm going to try x equals -3. And when I plug in -3, I get y equals -3 plus 2 squared plus 3. That equals 2. So when x is -3, y is 2. And I'm also going to try x equals -5. So I'm going to plug that in. X equals -5. So I'm going to plug that in. Y equals -5 plus 2 squared plus 3. That's going to equal -6. So I have -5, -6. So I'm going to hopefully have room over here. So -3 goes to 2. That means I also have 1 here because I'm going to draw the reflection. And -5 goes to -6. 2, 3, 4, 5, 6. So it's going to go down this way. But now from here, I'm over 1, 2, 3, 4, 5. So I'm going to go over here, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm just graphing the reflection. And there is my graph. Okay. Sorry it ran into all the work there. Okay, we're going to do about 4 more, I think. Okay. So here's one. My vertex is -2, comma, -5. Maybe I should write on this side. I'm going to write on this other side because I think we're going to be graphing over here. So my vertex is -2, -5. -2, -5. So there's your vertex. It's going to open up because this is positive here. And then my axis of symmetry is x equals -2. Now what I'm going to do is, since it's going up, I'm going to try x's, let's see, I'm going to try right here, I'm going to go, what is it at -3 and what is it at -3, and I'm going to also try what is it at -4. So I'm going to plug those numbers in. So this is -2, this is -3, so I plug that in. Y equals negative 3 plus 2 squared minus 5. That gives me negative 1 squared is 1, minus 5 is negative 4. So at negative 3 it goes to negative 4 right there. That means over here it's going to go right there. And now I'm going to also try negative 4. So I'm going to let x equal negative 4. You can plug in anything actually. But the closer you get to the smaller numbers, the easier it is to do it without a calculator. So we have negative 4 plus 2 squared plus 5. So that's going to be 2 squared. This is minus 5, sorry. So we have negative 2 squared is 4 minus 5 is negative 1. So negative 1 goes there. And what I'm going to do is from this axis of symmetry, I'm going to go over 2. So basically, there's 2 here and 2 here. And only 1 here and 1 here. And then I'm just going to graph it up. So let me plot those points here. So when x was negative 3, we got negative 4. When x was negative 4, we got negative 1. And I plot these 2 points, and then I just plot the reflections over the x equals negative 2 axis of symmetry. Okay, the next one goes down, opens down. Our vertex is 4, 1. So that's your vertex. 4, 1, 2, 3, 4, 1. It's going to open down. And then my axis of symmetry is x equals 4. We're just taking the h component here. So I'm going to draw that in. Now I know this opens down. I'm going to take 3 and I'll take 2 just to get this side. So this was 4, so this is 3 and 2. And I'm just going to plug in x. So y equals negative, and I'm going to plug in 3. 3 minus 4 squared plus 1. Evaluate that. Get negative 1 squared is just 1 plus 1. So that's going to be at 0. I'm going to put this at 0. Since it's at 0 here, it's going to be 0 on this side of the axis of symmetry. This is x equals 4. And I'm also going to try 2. So I'm going to write y equals negative 2 minus 4 squared plus 1. I get negative 2 minus 4 is negative 2 squared is 4 plus 1. That's going to equal negative 3. So let me write those down real quick. So when we went to 3, we got to 0. And when we went to 2, we got to negative 3. So 2 goes to negative 3 here. And I'm going to write, just plot the point over here that matches. And I graph it, and it opens down. Okay. All right. 2 more. I'm going to graph this one. So basically, if I rewrite this, this is x minus 0 squared plus 3. So my vertex is 0, 3. And my axis of symmetry is x equals 0. So there's your axis of symmetry. My vertex is at 0, 3. I know this opens up. So basically, maybe I'll just take these 2 points. I'm going to plug in 1 and 2. So when x is 1, what's y? When x is 2, what's y? And I just plug it in here. So when x is 1, I get 1 squared plus 3, and that just equals 4. So 1 goes to 4. That means, let me do this in purple. So that means it's going to be symmetric. So I'm going to put the other dot over here, the point. Now when 2, what happens with 2? So y equals 2 squared plus 3. That's going to be 7. 2 goes to 7. So 4, 5, 6, 7. And then I just make it symmetric over here. And then kind of try to connect it here. And you have your parabola opening up. And the last one we have is this one. So my vertex is 1, -2. Remember, you're always doing kind of the opposite there for that. The opposite and the same. So that's your vertex. So let's go 1, -2. This opens up. And my axis of symmetry is x equals 1. You're just taking the h part here. So I draw that. Axis of symmetry, which is x equals 1. And now from here, I'm going to go ahead and use 1 and 2. So what happens when x is, that's not 2, this is 2 and this is 3. What happens when x is 2? What's the value of y when x is 3? So I just plug it in. 3 times 2 minus 1 squared minus 2. And then we're just doing 1 squared is 1. Minus 2, so 3 minus 2 is 1, so we're going up to 1. This equals 1. And when I plug in, oops, that doesn't look good. So 2 comma 1. Now when I plug in 3, I get 3 minus 1 squared minus 2, and that's going to be 3 times 2 squared minus 2, which is 12. This is 4, so 3 times 4 minus 2, which is 10. So with 3, it goes to 10. So 2 goes to 1, and 3 goes to 10, which is way up here. Now I'm just going to make this symmetric. It goes over 2 here, over 2 here, and this just goes to 1. You can tell this is very narrow. Why is it narrow? Oops. You know I can't draw. Okay, so it's very, very narrow. Something like that. It's narrow because of this vertical stretch is 3, so that's why it's narrow. Okay, the next video we're going to do is where we have to put a quadratic function that's in standard form and write it in vertex form. And I don't know, do we need to graph it? Yes, then we will graph it as well. And I hope you all have a nice day.